I'm very glad to be able to present this to you tonight. I hope that you are all going to learn something great tonight. I'm going to start out by saying that there are a couple of apps that you might want to pick up for your phone. One is called Sky Maps if you're on an iPhone, and the other is called Star Tracker if you're on an Android OS app. So those two apps for your phone might help you find these stars in the sky a little easier in the night. But beyond that, let's go ahead and dig into this star's honor. So the first question on the star's honor is, what is the Earth's nearest celestial neighbor? And what is its distance from the Earth? Well, here you can see the moon right here, or the Earth right here. The nearest celestial body is the moon. So that's the first answer. And it has an average distance of 240,000 miles. So that's how far away the moon is from the Earth. It takes multiple days to get there, and quite a ways. So the next question, what governs the tides? Well, so the water is attracted by gravity, right? So water is a liquid, it moves, it can, and so the tides are that liquid being attracted to gravity. So our two major influencers of the tides are the moon. So the moon, as it moves around the Earth, kind of shifts that water with it, and that's the major tide variant. But it's also attracted by the sun, and so the sun is the other influencer. Those are the two things that govern the tides. Let's go to the next one, which is what causes an eclipse. So an eclipse is where you can have a lunar eclipse or a solar eclipse. Okay. So that's basically when you're on the Earth and you're looking up into the sky. A solar eclipse is when something is between us, your view, and of the you and the sun, right? So the moon, as it orbits around the Earth, comes over here and gets in between the sun and the Earth, and that blocks your view of the sun. Now, there's also a thing called a lunar eclipse, where it's the Earth is between us and the sun, right? So between, let's see, the sun, Earth, and then the moon, right? So basically, it's about shadows, right? So an eclipse is caused when the sun, the Earth, and the moon are in a direct line with one another. When the Earth is between the sun and the moon, we see a lunar eclipse, which is the Earth's shadows falling on the moon. And when the moon is between the sun and the Earth, we see a solar eclipse, which is the moon's shadow falling on the Earth. That's blocking the sun. All right. I think we've gone, that horse has been kicked dead. All right. What is a shooting star? All right. Well, it's not a star. We'll start with that. A shooting star is actually a meteor. So it's anything that is coming into the Earth's atmosphere, usually quite fast and usually quite small, and it's falling to the Earth. And as it does so, it gets really hot, and most of them burn up in the atmosphere before they even reach the surface. So they'll leave a bright, long, short-lived streak in the sky. It's not a comet, so a comet is something completely different. And I'm not sure if we talk about comets in this star's honor, maybe in the advanced honor, but that's a totally different phenomenon. So, but a meteor is basically that anything that's falling into the Earth's atmosphere, burning up and leaving a trail. That's a shooting star. All right. So that covers the first major questions in the star honor. The next one is it's make a diagram showing the relative positions and movements of the Earth, Sun, and Moon. Well, that's this, okay. So what we've got here is the Sun in the center of our galaxy here. the Earth moves around the sun, and the moon moves around the Earth. So that's the basic diagram. It's pretty straightforward. Hopefully there's not too many questions there. All right. The next one, make a diagram of our solar system and be able to name the planets in order from the sun. All right. So typically when you do this exercise, you get something that looks like what I have on the screen right now, right? You've got a bunch of planets on kind of arcs going around the sun. And what you don't see generally in these diagrams is actually those arcs aren't all like falling like they are, like all straight here, right? You've got some arcs off at an angle. You know, they're angular around the planet, around the sun. Without getting into too much detail, though, let's just list the planets. So, you know, we want to start kind of the closest to the sun is Mercury. The next planet out is Venus, followed by the Earth and Mars. So Venus, Earth, and Mars, interestingly, are in an area or distance from the sun we call kind of the green belt zone. So this is where the planets may support life, right? So we're talking about colonizing Mars, you know, possibly. Well, we can possibly do that. It's a little cold there. I think the hottest it gets is about 57 in the day. So that's a little cool, but that's possible. So moving out beyond Mars, and this diagram doesn't show up, but there's an asteroid belt as well. Something broke up and is orbiting the sun as well. But beyond that, planet-wise, we have Jupiter, Saturn, Uranus, Neptune, and Pluto is no longer considered a planet. It's a little sad, but unfortunately, we lost Pluto. It's now not a planet. To be a planet, it has to orbit a star. Well, that does that. It has to not orbit another planet, such as a satellite, and it has to dominate the vicinity of its orbit. So, unfortunately, Pluto's orbit is dominated by Neptune, and so it's not a planet anymore. So the planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All right. All right, before we move on to that. All right, so the next question on the star honor. How fast does light travel? Well, it travels at the speed of light, right? Okay, so it actually travels at 186,000 miles per second. That's not miles per hour, that's miles per second, so super fast. It's also 300,000 kilometers per second, if you're into the metric system. So in 1 year, light will travel 5.88 trillion miles, or 9.4 quadrillion kilometers. That's the distance that's called a light year. All right. So that's how fast light travels. All right, next question. What's the difference between planets and fixed stars? Okay. So the word planet, the actual definition of that, it means wanderer, because the planets appear to wander around the sky relative to the stars, right? So these planets are orbiting the stars, okay? The stars do not move in relation to one another, although they appear to move together because of the Earth's rotation on its axis. So that's the definition of a difference between planet and stars, okay? So, next one, identify in the sky 8 fixed stars. So we're going to do that. We're going to get to that in a second. We also want to work on constellations. And we're going to do these both at the same time. So what is a constellation? It is here is divided. term is also often used less formally to denote a group of stars visibly related to each other in a particular configuration or pattern. So that's the way I actually think of constellations. So constellations to me, are groups of stars, and over time, these groups of stars have been kind of separated, and patterns have been assigned to them, and which makes them easier to find in the night sky. So with all that said, let's start and look at some constellations. So here we in the northern hemisphere, we often start with the Big Dipper, also known as, well, it's Ursa Major and Ursa Minor. That's also known as the Big Dipper and the Little Dipper. These are probably some of the easiest stars to find in the night sky. In India, the Big Dipper is also known as the Bear. That's kind of Ursa, right, in the U.S. here. So the Bear, or that's the way it was known. It's now known as the Seven Sages in India. Or in Arabic, it's Dubay, I think. I'm probably killing that pronunciation, but also the Bear. So those are the Big Dipper and Little Dipper. Now, within the Big Dipper and the Little Dipper, there are some very important stars, most specifically in the Little Dipper, but you use the Big Dipper to find it. So Polaris is known as the North Star, and it's known as the North Star because it is the star that if you are trying to find your directions at night, that's the one you want to find because it's always north. It's always the north. So you can set your compass to it pretty much. To find it, we start out by looking for the Big Dipper, and you can see the Big Dipper, it just looks like a big dipping bowl, right? I mean, it's got kind of that dipping bowl shape to it. And you use the last two stars, well, I call them the last two stars. The stars in the cup, the farthest point in the cup, are Merit and Louis. So those stars, if you draw a line through those stars and extend it out, it's going to come into contact with Polaris, the North Star. And that is also the farthest star up the handle of the Little Dipper. So as you can see, you can find these bears in the sky or dippers in the sky, and that will point you to the North Star. All right, Orion, one of my favorites, very easy to find. It's very recognizable by these three stars on the belt right in here. I don't know if everybody can see that or not, but those three stars are usually very visible. They're very bright. They're also known as the Three Sisters. Orion has been called the Mighty Hunter. Kind of looks like, the hunter with his drawing the bow and arrow here. So that's kind of the what it looks like. So this one also has different names. This constellation. I'm probably gonna kill this, but Yada or Murga in India, and I know I'm gonna kill this. Heihionakaiki in Polynesia. And I'm sorry for the pronunciation, but a lot of these constellations are known in different cultures by different names, so it's important to understand that as well. Within Orion, so again, here's the three sisters along Orion's belt. There are two very bright stars as well, Betelgeuse and Rigel. So Betelgeuse is kind of up here, and Rigel is down here on kind of the foot and the arm, I guess, of Orion. But those two are very recognizable stars in the constellation Orion. All right. Next one, Cassiopeia. So this one is also pretty easy to find. So if you are looking, again, kind of looking along the stars of the Big Dipper and you go to Polaris, if you extend that line out even farther, and maybe just a little bit at an angle, you're going to find Cassiopeia. This cluster of stars was named after the Queen of Ethiopia, and she's the mother of Princess Andromeda. In Welsh, this constellation is referred to as Lystone. Again, probably butchering that name, but it's another name for this constellation. And this is one of those constellations that's generally visible all year long. All right. Let's see. The next one, Bucques. So this one is the home of Arcturus, the third brightest star in the night sky. So on this one, you find it by following the arc made by the handle of the Big Dipper away from the bowl. So I'll go back onto this one. So in this case, this Arcturus, if you follow this line around and you keep going around, it's going to come and hit Arcturus. And from Arcturus, you can find the rest of this constellation. And so in this one, it's a guy. It's supposed to be a guy. He's supposed to be a trapper. But in the Native American language, Yupik, it's also called Talulak. It's because it kind of looks like a fish trap. You know, it's kind of got this trap going on here. All right, let's see what is next. So the summer triangle stars. So these are kind of fun to find. They're pretty easy to find once you recognize them. You find them in the sky. They're very easy to find. But these have some very recognizable stars in them. Altair, Cygnus, and Lyra. So Vega in Lyra is the brightest star in the summer triangle. So Vega up here, right up in here, is a constellation, the constellation Lyra. And then Cygnus is also known as the Northern Cross. So that's this right up in here. And then Altair is in the constellation Aquila. So together, these three stars, Altair, Cygnus, and Vega, or the constellations, form this summer triangle. So you're going to find these constellations in the summer. All right. So that's kind of the fun stuff here. Let's move on into the next few questions. So it's asking us to draw a chart of the Big Dipper, Cassiopeia, and the North Star. Well, we did that. There's your Cassiopeia, the Big Dipper, and the North Star. That's the one you want to draw. I don't know that there's anybody on the call from the Southern Hemisphere. There might, but I did not draw a chart of the Southern Cross, Orion, and Scorpio, but that's the other one that they want you to draw for this honor. All right. All right, so what is the Milky Way? And we're asked to observe the Milky Way in the night sky. All right, so you have to get away from a city in order to really see the Milky Way. Here in Utah, there's some great places to observe the Milky Way. You can go down towards Moab and Lake Powell, Great Basin. Those are wonderful places to observe stars in general. But basically, the Milky Way is a large gathering of stars and bodies making up one of many galaxies. So it's a large cluster of galaxies and stars and so forth. We can only see part of it from the Earth. So it's let's see here. Not sure if something came up on the screen here. So the portion of the night sky is only a single dimensional or flat view of the galaxy, as our solar system is part of the same galaxy. We have a lack for a broader perspective. So we have to when you see the pictures of the Milky Way, the animations and so forth, those are graphical renderings based on what we know about the stars and the distances and angles that we are able to see. So that's how we know what the Milky Way really kind of looks like. But we can also see other Milky Ways out there, right? So there's others that are out there, and we can imagine what ours looks like. Next question is, what is the morning star and the evening star? Why does it carry both names? All right, so this isn't really a star at all. It's a planet. It's Venus. So if we go back to our planets here, it's one of the planets closest to us. And basically, it draws in part its modern status as the morning star and evening star from mythology. It's actually taken from that. Venus never appears on the opposite horizon from the sun due to its relative location to the sun and Earth. Again, it's between us and the sun, right? So Mercury also fits that same profile, but it's rarely actually visible. It's a very small planet. So we generally see Venus as the morning star and the evening star. All right. The next one, zenith and nadir. All right, this is a little more complicated to explain, but I will do my best. Zenith is the point in space directly overhead. It's that simple. If you extend a line from the zenith to the point on Earth upon which you are standing and continue that line through the Earth and out the other side, it would point to the nadir. Okay, in other words, the nadir is the direction pointing directly below a particular location on the Earth, all right? The line connecting the zenith and the nadir passes through the point on Earth where you're standing and also passes through the center of the Earth and out the other side. I hope that makes sense. I don't have a graphic to explain that, but that's what the zenith and the nadir are. All right. Next one. What is the aurora borealis and what causes it? All right. So our planet has a magnetosphere. It's a magnetic shield, essentially. Okay. And the sun is constantly spewing out particles, so ions, atoms, molecules, all kinds of stuff. I mean, it's a giant molecular incubator. It's just throwing stuff out into the galaxy as a part of its fire, basically, right? And the only reason we don't burn up is because we have this magnetosphere that protects us, okay? So the magnetosphere, when those particles hit the magnetosphere, they interact, and they are moving at such a high velocity, there's an energy associated with them as well. So the energy, if you've ever seen a gas sign, right? So when you put energy into a gas, some gases, right, they will light up and create different lights. That's exactly what's happening here. The immediate causes of the aurora are precipitating energetic particles. Particles are electrons and protons that are energized in the near geospace environment. The energization process draws its energy from the interaction of the Earth's magnetosphere with what we call that solar wind, all those particles coming out. And it's a beautiful phenomenon. If you ever see it, you generally would see it in the northern or very southern parts of the Earth. Canada. Sometimes it gets as far south as Maine, New York, but very far north. That's generally where you're going to see it. Alaska is a perfect place to go see it. All right. Then last question on this honor is discuss the statement made by Ellen G. White in Early Writings, page 41, concerning the opening of Orion. So let's go back to Orion here. All right. Again, the mighty hunter. Here's what was written in Early Writings on page 41. December 16th, 1848. The Lord gave me a view of the shaking of the powers of the heavens. I saw that when the Lord said heaven, in the signs recorded by Matthew, Mark, and Luke, he meant heaven. He said earth, he meant earth. The powers of heaven, sun, moon, and stars. Heavens, the powers of earth, are those that live on earth. The powers of heaven will be shaken at the voice of God. Then the sun, moon, and stars will be taken out of their places. They will not pass away, but be shaken by the voice of God. Dark, heavy clouds came up and flashed against each other. The atmosphere parted and rolled back. Then we could look up through open space in Orion, whence came the voice of God. The holy city will come down through that open space. I saw that the powers of earth are now being shaken, and the events come in order. War and rumors of war, sword, famine, and pestilence are first to shake the powers of earth. Then the voice of God will shake the sun, moon, and stars, and this earth also. I saw that the shaking of the powers in Europe is not, as some teach, the shaking of the powers of heaven, but the shaking of the ancient nations. So that's some passages from early Ellen White writings, page 41. All right, so basically the statement clearly mentions the events that would occur during Christ's second coming to this earth. Okay? The passage also mentions that God's voice would be heard through the open space in Orion, and also the New Jerusalem would descend from that open space. It is in agreement with the Holy Bible in Revelation 3:12, which says, "Him that overcometh will make a pillar in the temple."
You're breaking up.
Oh, sorry. Thank you for speaking up. And so it says, "He shall go no more out, and I will write upon."
Lance, we can't hear you.
You've muted yourself, Lance.
How did I do that? There we go. Okay. How's that? Is that better?
Yes, thank you.
Okay.
You might want to just go back to what you just reviewed. Go back over, I'd say maybe a minute or so.
Got it. Okay. All right. So basically, the passage mentions that God's voice would be heard through the open space in Orion, and also New Jerusalem would descend from that open space. So it is in agreement with the Holy Bible in Revelation 3:12, which says, "Him that overcometh will make a pillar in the temple of my God, and he shall go no more out. And I will write upon him the name of my God, and the name of the city of my God, which is New Jerusalem, which cometh down out of heaven from my God. And I will write upon him my new name." So it also says the same thing in the book of Revelation, chapter 21, verses 2 and 3, which says, "And I, John, saw the holy city, New Jerusalem, coming down from God out of heaven, prepared as a bride adorned for her husband. And I heard a great voice out of heaven saying, Behold, the tabernacle of God is with men, and he will dwell with them, and they shall be his people, and God himself shall be with them and be their God." So the passage also mentions many things that would happen at the end of time, where it affects nature terribly, and also a war between world countries with no more peace and a safe place for humans. So I think, basically if you want to open it up for discussion, we can do that at this point, but that's pretty much what I've got for the Stars Honor tonight.
All right, we're going to ask if you all have questions, that if you would type your questions in the chat so that Lance can answer them.
I guess I need to figure out where's the chat session.
We'll let you know what the questions are.
Perfect, thank you.
Thus far, we have none.
Okay.
Pastor Hoy, you had some different star constellations the Navajo had names, didn't you? You were telling me about. You want to share a few of those?
Sure. The Navajo look at, as we look at the Big Dipper and the Little Dipper, they look at that as the great warrior, the Big Dipper, and then the Little Dipper is the lady who is home grinding. So the man is the hunter who goes out, and the woman takes care of the hearth and the home. One of the things that they say is that the home fire, the Hogan fire, never goes out. And so the North Star is an important star in their culture as well. But I would much rather hear questions from our audience, or if anyone in the audience knows more about the stars in your culture and you'd like to share, if you could use the buttons and raise your hand and we can have you share. All right, Mary.
Um,
Go ahead, Mary. Now you're breaking up, Mary. Oh, Mary, we need to unmute you again.
I have a very big fat.
oh, well.
So my screen is frozen. If you can unmute her. Mary, if you can type in the chat, please. We have one comment from Josue Ipañe. He said the slaves used the North Star to escape. So the American slaves used the North Star. It was an important star to them, and that's how they used it to escape north to freedom. Thank you so much for that comment.
Yes, thank you.
Go ahead, Mary. Ask your question.
Okay. Is the aurora borealis, from what I thought it was magnetic particles. Is that right?
It's particles hitting the magnetic field that we have around the Earth. The particles may or may not be what's called ionized, which is charged, but yeah, so it's not quite magnetic particles. It's actually charged particles hitting a magnetic field.
Oh, wow. Okay, that's cool.
Mhm.
Very cool. We used to get them in upstate New York once in a great while.
Very rarely they come far enough south to see them there. Yeah,
Yeah.
I lived in Maine and we saw it once or twice, and Washington State. Yep.
Yeah, same here. Just once or twice. That's it.
Yeah.
Thank you.
Mm-hmm.
Now the Cygna, that's the else.
All right, well, if we have no other questions, I want to let everyone know that the updated website there with the updated information. Please make sure you check it so that you'll know club directors, you received an email with those updates earlier this afternoon, and so you should check your emails. Lance, thank you so much. Iso, do you want to have final comments?
Yeah, I'd just like to thank Lance for preparing this for us. I thank everybody for joining us. I know some of you guys were trying to get on Facebook and you had to come over to Zoom. We're not certain why it would not load the Facebook. Several of us tried. We tried even multiple sites. It just wouldn't do it. So we're hoping it's their end, and we're hoping it's fixed by tomorrow morning. But we have recorded this, and we will be posting it on our Facebook page so everybody can see it, and you can let your friends know who missed it that it will be posted. And we thank everybody. We'll see everybody tomorrow morning.
Thank you.
Thank you.